Hello again. So today what I'm going to do is explain the lab that we're going to do tomorrow during class. So it's really important that you understand the procedures of the lab so that tomorrow when you come in you can just get your equipment, get in your lab groups and start working. The lab that we're going to do, it's lab 1 and it's called How Far Around. This is the title of the lab. You can rename it later on if you want, but this is generally the name of it. The purpose of this lab is to give you practice measuring and graphing data. So as far as physics goes, this isn't a high-level lab, but I'm just trying to get you experience of taking data, creating a data table, and from that data table graphing it and using the information on the graph to determine your what you're looking for. Okay, so the purpose once again is to give you practice measuring and graphing data. The materials that we're going to use, we're going to get a meter stick, you're going to get some string, and you're going to get some different circular objects. So each group, and we'll have I'll have the names of everybody on a lab group when you come in tomorrow. Okay, so the procedure of the lab, what we're pretty much going to do is you're going to be measuring the diameter and the circumference of different objects. So for instance, you get a cylinder and then this long thin rod and then maybe a sphere. What you're going to do is you're going to use the meter stick and the string to measure the diameter and the circumference of different objects. You're measuring the circumference. You're not going to be using your known value of 2 pi r to determine that circumference. You're going to measure the diameter using either the string or the meter stick, and then you're going to measure the circumference using the string. Then you're going to set up a data table here. So you're going to have the objects and you can either draw them or label them or give them a name. You're going to record your diameter and you're also going to record your circumference measurement on that. When you make the data tables, you have to make sure that you label them fully and you give them units. Over here, make sure if you're measuring your units in meters that you have that diameter in meters and your circumference in meters. If you're measuring it in centimeters, make sure it's in the appropriate units of what you've done the measurement in. Then from the record that you're going to have your data table, now you're going to create the graph. What you're going to do is you're going to create a graph using the circumference versus the diameter. The thing with the graph, it has to be on graph paper. I don't want you coming in with lined paper with a graph done on that with little tick marks along that side. Make sure that it is done on graph paper. The key to using graphs in physics is to make sure that you use 100% of the graph paper. So even if your data is only this big, you want to make sure that you utilize that whole side of the paper. So your graph should take up a full page of the paper. Make sure that it's not this small little graph. And we'll talk about that tomorrow in class, how you can stretch out your data points to include a whole sheet of paper. And make sure once again that your graph has to have a title on it. The axes have to be labeled. The units have to be labeled as well. Then what you're going to do is once you've plotted your points on that, you're going to determine the value of the slope using your delta y over delta x formula. We can talk more thoroughly tomorrow in class if you have problems with that. One big thing here is when you're using the slope, make sure you're using the slope of the best fit line. Don't take 2 of your data points and figure out the slope from that. We're now using the best fit line. Okay, so the big question is what do you need to do to hand in? The lab will be due to not tomorrow. Tomorrow you're going to conduct the lab. It'll be due the next day in class. What to turn in. You're going to actually have a lab report. You're going to turn in the title. You're going to name your lab, and you can use the name that I've given it. The purpose. What you're going to do is you're going to take the purpose that I gave you on the first slide. Materials, what you use to do the lab. If you didn't use the meter stick, don't put it down. Make sure that, or if you decided to use a different type of measuring device, make sure that you've used all the equipment that you have used and do not include equipment that you did not use, even if it was suggested in the lab. The procedure, what you're going to do is it's just a short recipe of what you did. And this should be numbered in outline form. Number 1, procured all my equipment. Number 2, measured object number 1, determined the diameter. Number 2, determine the circumference, just along that line, but just short little blurbs of what you did. And number 5, you're going to create the data table. Now in this lab, I've put that data table out for you so you can just copy what I've done on the previous slide. Make sure that the data table is fully labeled with headings and units. Then your final one is the graph. Once again, it's on graph paper. It's going to take up one full sheet. Now a couple people have asked me in the past, can I use spreadsheet and have my computer program develop the graph? That is okay as well. What you may not do is come in either with a lined piece of paper and hand-drawn graph or on a plain white piece of paper. It is either on graph paper or done from home using a graphing program. Okay, and once again, make sure that it's fully labeled, that you have your scatter plot of your points and a best fit line. The next section is going to be your calculations. In this lab, the only thing that we're calculating is the slope, so that's not going to be a problem. Later on, there might be 2 or 3 different calculations that you're going to be doing. So in this case, you're going to calculate the slope, which is your change in y, and make sure you show all your work. Do not just give me the value of the slope. And then the last one is your error analysis. And this is something that we talked about, the error that's intrinsic in the lab. What you're going to do is you're going to take that experimental value of the slope, which is what you've determined over here, minus the actual value. And as you do the lab, you're going to realize what that slope means. And then it's all going to be over the actual value, and then you're going to multiply it by times it by 100, and you're going to get a percentage. Hopefully it's not a 90% error rate, but you're going to get a lower, maybe you'll get a 1% error rate, and that'll tell you how much error is involved in the lab that you've done. Okay, and that is all that's for this lab. We'll see you tomorrow. There is no homework for this lab, so just come in prepared. Make sure that you bring in graph paper and any paper that you're going to need for conducting the lab. We'll see you tomorrow.